So, good morning to all of you. So, last class we discussed about digital logic gates. In that we discussed AND gate. AND gate having two inputs A and B. Then we can get the output Y is equal to the product of the inputs A and B. And NOT gate, that is a NOT gate having only one input. The output is the inverse of the input A. That means input A for the NOT gate, the output is the inverse of the input, that is A bar. And also we discussed the truth table. If the inputs are given the binary input, that is a 0 and 1. The next we discussed about OR gate. Right? OR gate also having two inputs A and B. The output of the OR gate is nothing but the sum of the two inputs. Y is equal to A plus B. And the next we discussed about the NAND gate. NAND is nothing but it is the combination of the two gates, AND gate and the NOT gate. So here also two inputs and then and then we are getting the output, only one output. And we discussed NOR gate. Right? That means in this NOR gate, OR gate and NOT gate, the combination of two gates. What are those two gates? OR gate and NOT gate. So same, the two inputs A and B, and then we'll get the output Y. So in the OR gate, that is nothing but Y is equal to A plus B inverse, that is A plus B bar. Whereas in the case of NAND, it is Y is equal to A dot B bar, that is A dot B inverse. Then for all these things, we discussed the truth table. And then we discussed about the computer. What are the major components in the computer? That is the central processing unit, input and output devices, and the memory, that is the RAM and ROM. Those are three major components we discussed, right? Today we are going to discussing about the microprocessor and one microprocessor, that is 8051 microprocessor. Here there are several microprocessors there, but we will discuss 8051 microprocessor. Sir, why here in the syllabus it is not mentioned? So just to remember this point. In the syllabus, it is not mentioned the microprocessor name. So why here we are discussing 8051 microprocessor means in this the components are there. You have to know the function of the components. Same components are there in 8056 or 8085 also is there, and 80856 80 it is 8051. 8085 is there, 8056 is also there, another, and also advanced is there. These are all the Intel company. And then just we are discussing one microprocessor, that is 8051 microprocessor. So in that the components in which way they are functioning. So that one we will discuss. That is very important. The component functioning of the components is very important. Right. So now we'll discuss about so this is the block diagram of a basic computer system. What I said now, that is right. So here the central processing unit, right, and memory, RAM and ROM, and input-output sections are input-output devices. Here the CPU, in other words, we can also call it as it's as a microprocessor, right? Microprocessor. And ROM, all of you know that ROM is a read-only memory, and our RAM means a random access memory, and the input-output interface. That means inputs we have to give to the system, and then we can get the output, right? So this is the input-output device. This is the interfacing, and that means interfacing will be traveled through data bus. The data will pass us through data bus. And input output devices. What are the input output devices? Here the input is the keyboard, right? Mouse, and the output is the it will display in the monitor. Maybe, for example, if you open a calculator, the computer, if you, for example, 2 plus 3 is equal to, then automatically it becomes the output, right? From the calculator, we can get the output. For example, if you want to take a print, then if you automatically you can get the print through the printer. These are the output devices. హలో మేడం గారు, గుడ్ మార్నింగ్ మేడం. నేను క్లాస్లో ఉన్నాను మేడం. చెప్పండి చెప్పండి. ఓకే ఓకే. Right, here this is the control bus. That means why here the controllers here from the CPU, it is arranged the control bus, right? The control bus from the CPU. For example, see here, for example, why here for input and output interfaces, right? In the input, if you give with the help of the mouse or with the help of the keyboard, if you open one window, for example, browser window, you open it, right? And then another one Word document, you open it. That means you given two inputs. Say at the time you given, you opened one Google Chrome browser, and another immediately you opened a Word document. That means from the CPU, you given 2 or 3 inputs. So which one has to open? Which one has to open? That means this. That means when the browser Google Chrome will come, that is the output, right? When if you click the Word document in the desktop, that means it is opened, means that is the output, right? So here that means in between the here, see, from the CPU, if you use the input, that is Google Chrome, you click the Google Chrome, it is some process going on. That is, it sends to the CPU, right? And then which that means this control bus means it controls, that is which one open, that is maybe Google Chrome or Word document. Sometimes you can open a Word document, PDF, or some other Word, 2 or 3 Word documents immediately. So it will take some time. That is controlling. That is a control bus. You can call it a control bus. From the CPU, if you command, you input, and then you have to get output. That means you open the Word document, 2 or 3 Word documents at a time, then it will take some. That means it will take some time. This is nothing but we can call it a control bus. That if you here see interfacing, that means input/output interface. That interfacing will be controlling through CPU. This is that control bus. Control bus. For example, for one system, Xerox machine is there, and a printer scanner is there, Xerox machine. If you give one document printer, and if you give one document to another Xerox machine for taking print, here for a system, you are giving the output. One is printer, Canon printer example. Another one you can use Xerox machine, right? So if you give, so for 10 pages of document, if you give print to one system, and another 10 document pages if you give to the Xerox machine to print. So this means that these are all will be the, if you give the output, it will control. For example, if you go for companies and software companies or some other organization, there in the offices, for example, one station is there. So all 10 or 15 members are working. One station is there. There the printer, printing machine is there, a big printer. And then suddenly 3 or 4 members are given print. Which one has to come output? That is, which one will give output? These are all gives one by one. That is uniform. These are we can call as a control bus. These are control bus. Are you understanding? For example, in one station, for example, in office administration, any administration, 10 members are working in computer, and in that one station is there. That is a printer, scanner, all the things are there in that. In this 10 members, around 5 members given a print at a time. So the printer has to take which one? So that is the control. That is it will control. So there is no this without any disturbances. It will control. So that is the thing. That is the control. Here the control bus. It controls the input and output interfaces without any distributions from the CPU, right? I understand. Now we'll go for the next one. And see here, basic components of a microcomputer. So these are the basic components, right? What are the yesterday we discussed? The CPU, that is central processing unit, is the major component, the microcomputer. So that means here this CPU. Here, see here, this is the data in the instruction tells the processor what to do. What that means functioning. The data in the instruction, whatever the data, it tells to the processor what to do, which way it will function. That means all this is very, very sensitive. And then if you go and see that the primary element carrying out the computer's function, it is the unit that reads the executes program instructions. That means it reads and it executes the instructions. It reads and it executes. Executes means whatever the program instructions executes means it gives out. So it means according to the whatever is there, the primary, that means maybe some software, right? Like that, it reads and executes program instructions. That means it carries out a set of instructions of a computer program. Computer system is nothing but it carries out a set of instructions of a computer program. So this is a major one. This is a major one. This is a CPU. The CPU, it is a processor, is there, right? A major processor. See here, here it is clearly mentioned. A microprocessor is also known as CPU or central processing unit. It is a complete computation engine that is fabricated on a single chip. This is a single chip, right? So without this, the computer will not function. This is a major element, major component, right? The next, so memory. So if you go to memory, there are two, that is a random access memory. All of you know that is random access memory and read-only. Here, that means in the RAM, it can read and return to any time the CPU commands. It can read and return. Whereas ROM, the data, that means here that never changes. That is nothing but, for example, the ROM. For example, we have to install a software, Word software, or PDF, Adobe Reader, or some media player. So this will not, the software will never change. That means we cannot erase it. Cannot erase it. So that is a data with data and software that never change. We cannot change. For example, one antivirus software, we cannot change. So that is nothing but ROM, read-only memory. That means read-only memory means just the processor will read that one. It will not be written. There is no write-up. You cannot make any changes in that. We cannot. Right here, read means read-only memory means only it reads the data. It does not write. That write means here there is no changes. We cannot change the software. Am I right? We cannot change the software. For example, see, there are so many. For example, Windows 7. We have to install Windows 7, right? Or Windows 10. That one we cannot change. Cannot change it. That is the example I am saying. It will read the data, according to that it will install the software. Changes not happen. But in the RAM, we can change. The RAM is random access memory. It can read and write. For example, take the pen drive. Example, pen drive. It is, for example, you can read and we can write. So Word document we can change and then we can see. Or understand? This is nothing but hard disk, right? See here, we can, that means we can read the data and then we can also change the changes will happen in the RAM and then it will be stored in the RAM. Right. Now RAM, this one, all these components, again, we will discuss briefly. If you go for microprocessor architecture, we will discuss one by one component. In that RAM, ROM, with the help of the neat figure, I will give you a clear idea to you. Of course, you know very well, right? This RAM and this ROM is typically the computer's initial starts of instructions, right? So what we discuss now. So right, the next we'll go for the next one. So and this is the input and output interfaces. This is all of you know that input and output interfaces, right? Right. Here the outside, that means inputs or signals or data received by the system. These are nothing but what I said now, keyboards and mouse, right? Keyboards and mouse. Whereas the output here, the output, right? The outputs or the signals or data sent from it. You can get the output. So those are nothing but display, printer, hard disk drives, floppy disk drives, optical disk drives, and these are all output. These are all output, right? Right. This one you know very well, input and output, right? So the computer, the input or the signals, the data received by the system. That means if you use the input through a keyboard or mouse, these are the input peripherals, then it will receive. For example, scanning, right? And the outputs, that is the signal, the data sent from it. That means here the input and output, between these CPU is there. So some interaction, interfaces. Here CPU and input and output, right? So if you give the input through some process and then it reads the signal and then it processes the signal and then we can get the output, right? Through some output peripherals. So what are that output peripherals here? The display, that is a monitor, right? Hard disk drives, so floppy disk drives, so optical disk drives, and also printer. That means a scanner. Scanner. There are so many output peripherals. Okay, this one you know. Next we will go for 8051 microprocessor architecture. So in this here, if you observe, CPU, right? CPU, right? Here, all these from the processor, all these are components are there, work together. So then only the computer system will run. Otherwise, it will not work. Here, the CPU, right? If you see CPU here, this is OCC component is there. It is oscillator, clock circuit. OCC means oscillator clock circuit. And then here in this interrupt control, right? This CPU, for the CPU, input is interrupt control. If you see here, this is the interrupt control, right? This is the interrupt control. In this interrupt control, these are the three or the internal interrupt sources. All of you listen carefully. So for the CPU, from the oscillatory clock circuit, it is the input to the CPU, the processor, and the interrupt control is the input to the processor. Here the interrupt control, in the interrupt control, three internal interrupt sources. These are the these three arrow diagrams. Don't draw, for example, in the architecture, SAR is written 3, I will written 4 or 5 like that, no problem like that. So that is not correct. Here, 3 are written means 3 internal interrupt sources. For the interrupt control, these three arrow marks indicates three internal interrupt sources. And here these two are the two external interrupt sources. Two external interrupt sources. Now you get the clear. And then next, this is a 4K room. 4K, that is bytes, 4K bytes, right? ROM, read only memory. Right here, 128 byte RAM. Here I not mentioned arrow mark, right? Here we have to draw like that one. And then this is the bus control. In the bus control, two ports are there again here. You see here, now this section is over. And now we are coming to the section, ROM and RAM, right? ROM and RAM, right? And then this, you see here, this one, it is a bus control. In the bus control, two ports are there, right? And the next, this is the RAM. And for this RAM, it is a 4 input/output ports. This is a P0. What are those 4 input and output ports? P0, P1, P2, P3. These are the 4 input/output ports. In this, each one, 8 ports are there. 8 ports are there. 8 ports. P0, 8, P1, 8, P2, 8, P3, 8. And these are the serial port, TXD and RXD. TXD and RXD. So one is output, another one is input to the serial port. And here these 2 timers are there, 2 timers, timer 1 and timer 0, and counter inputs. That means 2 counter inputs. That means in this 8051 microprocessor, 2 timers and 2 counter are the inputs to the timer. These are the inputs. So this oscillatory clock circuit, in this oscillatory capacitor, symbol is the capacitor, right? And it is connected to the ground. This is a ground. Then again, I am repeating, all of you see here. Why? It's just I am discussing the components. And next, who will discuss the functioning and of each and every component. So for oscillatory clock circuit and interrupt control. What is interrupt control? What is internal interrupt? What is external? What is a ROM? What is a RAM? And what is bus control? What are these 4 input and output ports? Serial port, timer, counter, all these things we will discuss. The functioning of each and every part we will discuss one by one. Again, I am repeating, all of you see clearly here. In this, CPU, here in this oscillatory clock circuit, you can also call it as oscillatory clock pulses. So, right. And this is here, this round is nothing but, if you see here, this is nothing but this quartz material crystal, quartz crystal, right? And this CPU interrupt control is the input to the CPU. In this interrupt control, 2 external interrupts, 3 internal interrupts. These are the three, these are the 3, right? These are the 3 internal interrupt sources. Again, I'm doing the interrupt control, 2 external interrupt sources. These are the 2, and 3 internal interrupt sources, and 4K ROM, 128 byte RAM. So now microprocessor is updated. There is a RAM. In other words, we can use the fastness to the fastness to the system, to the processor. That means to the CPU. Then this is the bus control. In the bus control, 2 outputs are there, and in these 4 input and output ports. That means P0, P1, P2, P3. Each port P0 having 8 ports are that. That is P0.0, P0.1, P0.2, P0, 0.3 like that up to P0.7 like that. And serial port TXD and RXD. These are all we will discuss. In the next coming, we will discuss TXD. What is the functioning of TXD, RXD, and timers. Two timers are there, and two counters are the inputs. These are all the things we will discuss. The functioning of the component one by one. Right? So, what is CPU and what is OCC? Interrupt control, ROM, RAM, bus control, 4 input slash output ports, TXD, RXD, serial port, timer, counter, all of this. We'll discuss. Then this microprocessor topic will be completed. So next, we'll discuss. So now this is the pin diagram of Intel 805 printer, right? See what I said now. See if you see here, what I said. P, that is P. 4 input ports I told you, right? This is the P0, right? And this is the P1, right? And this is the P2, right? And this is the P3. In this P0, what I said, 8, that is 0 0.0, 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, 0 0.6, 0. Likewise, same similarly, 1.0, 1.2. For all these things, 8. This is total 8. This is total 8. 8. And this is also total 8. And this is also total 8. And this is also total 8. That means this Intel 8051 microprocessor having 40 pins. 40 pins. 40 pins. This is the pin diagram. Right? Intel 8051 thing 40 pins. 40 pins. 40 pins. Here, if you see these 4 input and output ports, each pin 8. P0 having 8 and P1 having 8. Like that, 8 ports are 32. Right. This is a 32 input and output pins grouped as 4 8-bit ports. That means 32. These are 32. 32. So what we discussed about, right? See here. These are the here. P0, P1, P2, P3, right? These are the 4. These 4, 4 into 8, each contain 8. So 4 8 is 32, right? 32 discrete input and output grouped as 8-bit ports, right? These are 8 bits, 8 bits. Then this it consists of 8-bit ALU, arithmetic logic unit. ALU means arithmetic logic unit, and this with 2 registers A and B. So it consists of, we will discuss the registers function. We will discuss what is ALU also. We will discuss ALU and register also we will discuss. And it is a 16 program counter and a data point. It is this 8051 is a 16-bit program and 8-bit ALU. And 8-bit program status mode, 8-bit stack pointer, 128, already we discussed the 128 bytes RAM, right? Right? And internal ROM, it's a 4 KB, I already 4 kilobytes, right? 4 kilobytes, 4K bytes. It's here we discussed already. This is 4K bytes, right? This is 4K right here. This is 4K bytes, all right? And 128 byte RAM. And this is timer counter. So the time is here. In the internal ROM, it is 4 kilobytes and 128 bytes internal RAM. Yes, are you understand? And then see here, it is a 216-bit timer and counter T0, T1, right? 216-bit. That means 2. Yes. Right, it is 216-bit, correct or wrong? Here, this is 2 timers, right? 1 minute. 2 timers. These 2 timers are 16-bit. 2 timers and counters, same. So see here, this is a 2 16-bit. It is a 16-bit timer and counter T0 and T1. and 2 external, what I told to you, that is 2 external and 3 internal interrupt sources, right? 2 external and 3, that is a 2 external, see here, 2 external, this is the 2 external, right? 2 external and 3 internal, right? Interrupt sources. 2 external and 3 external and 3 internal interrupts. And control registers, TCON, and these are all TMOD, SCON, and we will discuss that. And oscillatory clock circuit, right? So these are all the 80519. Here in that ALU is not mentioned and register, right? We will discuss there. Now next class we will discuss about what is a CPU, what is a OCC, and interrupt control, internal interrupt sources, external interrupt sources, ROM, RAM, 128 byte internal RAM, bus control, input output ports, and next TXD, RXD. See here, these are this TXD, RXD, these are this INT01 is nothing but timer. So the timer. And WR, RD, T0, T1, LEA, PSEN, all these things points we will discuss, right? These are all would XTALT, AL1, this is XTAL1 and ALT, XTAL2. These are connected to the oscillatory clock circuit. These are connected to the oscillatory clock circuit. I understand. These are all we will discuss. XTAL1 and XTAL2 we will discuss, right? And P01 to 07, 1 to like this, all this EA and ALE, ASEN, reset, right? And RXD, TXD, all these things we will discuss. The next class we will discuss elaborately the functioning of each and every element in microprocessor. And then here, so my here some of the members are not registered in TCS. Those who are eligible, of course, eligibility candidates are there. Already in mechanical CRT, Rajesh sir is posted. I hope so. All of you see. It is only 21 members left. By today evening, all of you register in TCS. And also you can fill the Google form. Again, I'm repeating. నేను చెప్పాను already. మీరు అశ్రద్ధ చూపబాకండి. Don't neglect whatever the drives, placement drives come here in our campus. చాలా చెప్తున్నానమ్మా మీకు చాలా ఇబ్బంది పడతారు మీరు. నేను చెప్పాను మిగతా 21 మెంబర్స్ ఏమనుకుంటున్నారంటే మా కోర్లో వస్తుంది, మేము కోర్లోకి వెళ్తాము అనుకుంటున్నారు. ఇట్స్ నాట్ కరెక్ట్. అది వెళ్ళండి, నేనేం సార్ వీఆర్ నాట్ అబ్జెక్టింగ్, ఎవరు అబ్జెక్ట్ చేయను అన్న మిమ్మల్ని. ఇక్కడ మనకు వచ్చిన దగ్గరికి వచ్చింది ఆపర్చునిటీ యూటిలైజ్ చేసుకోండి అంటున్నా నేను. వచ్చింది అనుకోండి, వెళ్ళండి గుడ్. మీకు ఫర్ ఎగ్జాంపుల్ మీరు అనుకున్న కోరు వెదర్ యు ఆర్ ట్రైయింగ్, మీరు రాలేదనుకోండి, అప్పుడు ఈ జాబ్ చేసుకుంటా కూడా మీరు కోర్లో జాబ్ సంపాదించుకోవచ్చు. మీకు అర్థమవుతుందా మనం చెప్పింది? ఆర్ యు అండర్స్టాండింగ్? నాకు డోంట్ నెగ్లెక్ట్, నన్ను నెగ్లెక్ట్ చేయబారు, తర్వాత చాలా బాధపడతారు. నేను ఇప్పుడు మనకు వచ్చింది, మనకు ఆపర్చునిటీ వచ్చింది, ఎక్స్పెక్టేషన్ చాలా ఉంది నాన్న. ఈ టీసీఎస్లో చాలా వేకెన్సీస్ ఉన్నాయి, మీరు అనవసరం చేతులారా పోగొట్టుకుంటున్నారు. మీకు కోర్ మీ ఇంట్రెస్ట్ ఉంటే కోర్కి వెళ్తాం, ప్రాబ్లం లేదు, నథింగ్. మిమ్మల్ని ఎవరు అబ్జెక్ట్ చేయరు. మీరనేది ఇక్కడ మనకు ఛాన్స్ ఉంది కదా, మీరు కొట్టేసేయండి జాబ్ ఈజీగా, కొట్టేసి నెక్స్ట్ కోర్కు ట్రై చేసుకోండి లక్షణంగా. ఎవరేమంటారు ఏమా అర్థమవుతుంది బాబు? బట్ డోంట్ వేస్ట్ ద టైం నన్ను. మిగతా 21 మెంబర్స్ ఈరోజు ఈవినింగ్ కల్లా రిజిస్టర్ కండి. బెటర్ రిజిస్టర్, దెన్ లెర్న్. ట్రైనింగ్ ఏమొచ్చి ఫ్రమ్ టుమారో ఆన్వర్డ్స్ ద ట్రైనింగ్ విల్ స్టార్ట్. ఈరోజు సమ్ టెక్నికల్ ఇష్యూస్ వలన some problems. So from tomorrow onwards, the training will continue. So up to the next month, 20th, and up to that, already I displayed, already I posted the revised timetable. Timetable is same. There is no change in the timetable, but only the timings are changed. So you have to follow the timings, correct? Now I will take the attendance. And see here, this is the 8051 pin diagram. Clearly, this is total 40 pins are there, right? 40 pins. Here it is given in different way. So no problem. Here P1.0 to P1.7 and reset is at here. But in our here I drawn here, the reset is mentioned at here in the beginning. Like this, no, just no problem. Huh? So this is one textbook. This one I written in one textbook. This is same whatever the pins are there yet here also, but it will be changes. That means position changes. So here reset is there. See here, see. This is the reset at here, right? And INT01, T01, T0 and T1 are the timers. These are the two timers, right? Counters, timers and counters, RD, WR, RD, and these are all the inputs, right? And P0, right? And supply, VCC supply, right? Here XTA-L1 and XTA-L2 is there. These are connected to the connected to the oscillatory clock circuit. Okay. If somebody said that have training, Rajesh sir posted revised timings in Telegram. Okay, if there is means, then you can attend, no problem, no issue. You can attend in LMS Digiversity. Okay, right, Rajesh? Rajesh sir post chesarannaru number 80. So according to that you can follow ma. Telegram group lo chudandi, dan batti meeru or you can attend. Okay, right? No problem. So now respond attendance one by one. Time is over. Again, 12 o'clock we were having class. Number one. Right, 4, right, 5. He is suffering from COVID. 7. Option to 7, 8 or 9. 9. 10. 11. 13. 14. 15. 16. 17. 17. Okay. 18. 19. 20. 21. 22. 23. 24. 25. 26. 26. 27. 28. 27. 28. 27 option 10. Okay. 30. Okay, right. 31, 31, 32, right, 33, 33, 33, 34, 35, 36, 37, 38, 38, 39, 41, 39 option to 41, right, 42, right, 43, right, 44, right, 45, 45, 46, 48, 48, 49, 50, 52, 50 option to me. 52, right, 54, right, 55, 56, 55 option. 60, all right, 61, 63, 64, 65, 66, 65 option, 67, 68, okay, 69, 69, 70, right, 71, 73, 74, 75, 76, 77, 78, 79, 78, 79 option, 78 present, okay, right, 80, 81, 79 option, 84, okay, 85, 86, 88, 89, 90, 91, right, 92, lateral entry 1, 2, 2, 3, right, 4, 4, 5, 6, 7, 8, 8, lateral entry 8, 9, 10, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 18 option, 20, 21, 23, 24, 25, 26, 25, 26, 27 present, 28 present, 29 present, right? 25 option, 30, right, 31, 32, 32 COVID, right, 33, 34, 35, 35 option, 36, okay, 37, 38, 38, 39, 40, 35 present, okay, 40, 40, 38 option present, 38, 38, right, 38 option, 43 present, 41 present, okay, 40, 38 present, okay, 40, 40, 40 option. Oh, so here the option is 5 is suffering from COVID, right? The 7 is also right. 7, 9 option is 9, 10, 27, 50, 55, 65, 67, 69, 79, lateral entry 2, 8, 10, 18, 25, 40. Anybody else? Okay. Thank you. Thank you all of you. All of you write the quiz exam. Quiz from 11:45 it is open, right? All of you write the quiz exam.